Now we're going to graph polynomials when it's given in factored form. So I'm going to walk you through 3 examples. Given the information that we've learned in class and that we know, we're going to put it all together. So here's your first example. If I give you the function y equals x plus 1, x minus 2, and x plus 3. What I want to do is graph it. Now before we do this, we're going to identify certain things. So I want you to tell me what the zeros are. So since it's in factored form, we can do this pretty easily. My first 0 is -1, my second is 2, and my third is -3. For these, the order doesn't matter. The next thing I want you to do is be able to tell me the y-intercept. So we know that whenever there's a point on the y-axis, that x is always 0. So if I were to plug in 0 for all of these x's, then I'm going to have 1 times -2 times 3, which gives me -6. So that means my y-intercept is 0, -6. So now I'm going to start to graph. I know that I have a 0 at -1, -3, and 2. I also know, since I just figured out my y-intercept, that it's going to cross the y-axis at -6. So next we're going to look at the leading coefficient. So the leading coefficient is positive, so we know in our end behavior that it's going to end up. And I can graph that now. Then we're going to identify the degree, which is 3, since we have 3 x values. So since it's 3, that means it's odd, so it's going to start down. So now, before we connect the dots, we want to check our multiplicity. Since they all have a multiplicity of 1, they're just going to go straight through. I'm going to be sure to hit my y-intercept. And there we go, I have my graph. Okay, so let's look at our second example. So since this is in factored form, we can identify the zeros, which are -2, 1, and 2. But we need to account for the fact that -2 has multiplicity, so I'm going to write -2 and then with multiplicity of 2, just to add that in there. So next I need to figure out my y-intercept. So if I set all the x's equal to 0, my first value for this first factor is going to be 0 plus 2, but then we need to square it, so it's going to be 4 times -1 times -2. So this is going to give me a y-intercept of 8, 0, 8. Alright, so let's plot those points, -2, 1, and 2, and then my y-intercept of -8. Alright, so my leading coefficient is negative, which means it's going to end on the right side down. And then the degree is 4, because we have -2 with a multiplicity of 2, 1 and 2, so that's 4 total. So therefore, since 4 is even, it's going to start down. So now we need to figure out how we're going to connect the points. And we can't go straight through them all. It's not going to work. We have to account for the fact that -2 has a multiplicity of 2. So since it's even, it's going to bounce and come straight back down through my y-intercept, up, and here we go. Now, we technically could do this, follow through the y-intercept, and then even come higher and down. It's not going to matter. The general shape is what we have in orange or red, as long as we have multiplicity and our end behaviors are correct and it's going through the correct x and y intercepts. That's all you need. Okay, now I want you to try this third example on your own. So pause the video now and identify the zeros, the y-intercept, leading coefficient, degree, and behavior, and then sketch your graph. Okay, so we have two zeros at 1, but 1 has a multiplicity of 3, and negative 2 has a multiplicity of 2. So I'm going to graph it. I'm going to graph those two values at 1 and negative 2. I'm going to figure out my y-intercept. So I'm going to have negative 1 cubed and 2 squared, which is negative 1 times 4. So my y-intercept is negative 4. My leading coefficient is positive, so it's going to end up on the right side. My degree is 5 because of the multiplicity of 3 and 2. So since it's odd, my end behavior is opposite. So now we need to connect, but keep in mind we have multiplicity. So we have multiplicity at negative 2 is 2, so it's going to bounce down. But then when we come back up, we need to account for the multiplicity of 3 and do our cubic shape. So it's going to look like this and have a cubic. We can even make it a little bit more cubic looking by coming out here like this. So there we go, some variety or variation of this function. This sketch represents that function. Okay, so the last example I'm going to show you is we're going to go backwards now. Here is your polynomial graphed. So what I want to do now is find the equation in factored form. So to do that, the first thing I'm going to identify are my zeros. I have a 0 at negative 3, negative 1, and 2. But note that 2 has a multiplicity of 2 because it bounces. So I'm going to write y equals x plus 3, x plus 1, and then x minus 2 squared. Now, what we're forgetting about, though, is forgetting about our leading coefficient. We don't know. We don't know what that is. So we are going to actually use the value of our y-intercept, which is 0, negative 3, to figure out what a is so we can have our whole entire factored form equation. So I'm going to take the x value of 0 and plug it into my equation, and the y value of negative 3, plug it in, and then solve for a. So it's going to look like this. Negative 3 equals a times 0 plus 3, which is 3, 0 plus 1, which is 1, 0 minus 2, which is negative 2, but keep in mind we have to square it. So that becomes 3 times 1 times 4, which is 12. So we have negative 3 equals 12a. I'm just going to flip the sides of 12 and a. Now we just solve for a by dividing by 12. So a equals negative 1/4. So that means that my final equation is y equals negative 1/4 x plus 3 x plus 1 x minus 2 squared. And then the other thing you just want to check is your end behavior. You have, and your zeros. So you have 1, 2, 3, 4, a degree of 4 because of this multiplicity at the end. And they're both going down, so that's good. And then they're both, since they're going down, that means my leading coefficient had to be negative, which it is. So you can think of things like that to check yourself.